but what they do is they sequence your SNPs. They're called single nucleotide polymorphisms. They're looking at changes in your DNA. Some people don't, but scientists don't know that much about all of that DNA. Honestly, what we really know a lot about is these SNPs, these single nucleotide polymorphisms. So that's what you're looking at. Now, what that means is essentially either you've got a defective copy from your mom or from your dad. That would be a plus minus. You know, if you had a good copy from your dad and a bad copy from your mom of the DNA, that's a plus minus.
Okay.
Folic acid is a fake chemistry chemical. It was developed in a lab. It's not found in nature. And
you are listening to the Optimal Performance Podcast. The OPP is brought to you by Natural Stacks, makers of 100% natural and open source supplements designed to help you live optimal. For more information on how to build optimal mental and physical performance into your life, go to naturalstacks.com.
Ryan Muncie is probably the smartest guy I know.
Trust me, Muncie is the nutrition guy.
Ryan Muncie's out there trying to make the world better for all of us.
The Optimal Performance Podcast is bold, edgy, creative, entertaining, and epic.
Ryan Muncie is my go-to guy.
Ryan Muncie he's the first guy I call.
He's making people's lives better. Ryan Muncie's an innovator.
All right, ladies and gentlemen, welcome back to the OPP. Today we are talking with our friend, Dr. Anthony J. Dr. J, welcome back to the show. Thanks for hanging out with us today.
Thanks for having me.
So, quick recap for our listeners. You appeared on episode 97, and that was a really fun episode, really educational. We talked about environmental toxins, artificial estrogens. If you guys haven't heard that one, definitely go back and listen to that. But Dr. J, if people didn't catch that one, I'm going to read your Twitter bio. Dr. J, scientist, simplifier, speaker, outdoorsman, Estrogeneration author. Find out more at
AJCCO.
Yeah.
That works too.
Okay. Anything to add before we go on?
No, that's good. I mean, it's funny because we mentioned 23andMe in the last time we talked towards the end. And I had a few questions from your listeners about that.
Beautiful.
Via email. And so it's perfect timing today to go back and revisit that topic.
Yeah, and that's exactly what we're going to do. For you guys listening, if you haven't been able to catch on to that yet by the title for this show, Dr. J has my 23andMe data. So anything we talk about today, he has my permission to say on the air. When you do this with him, it's all confidential. So, we'll put that out there for you guys right now. But there is so much more that we can do with our genetic data than we get from the 23andMe reports. And even their reports are incredibly, I don't know if overwhelming is the right word, because like I said, there's not like they're giving you everything, but there's just so much to sort through. And I'll be honest, I did 23andMe. It's been, I don't know if you saw the test date when you were able to log in or not, but it's been well over a year. And I've really done nothing with it other than to be able to say, you know what, I am in fact European. Who knew? And
your eye color and your skin pigmentation. I saw your 23andMe report, and it said essentially you had hair as a newborn. You're likely to have freckles, and odor detection. You're likely to be able to smell asparagus. It wasn't much more than that, honestly.
I can smell asparagus. I don't have. Well,
no, go ahead.
And the only other thing I'll say, and this is not to pick on 23andMe, but the only other thing I'll say is that, I did notice the athletic portion of it said that I had the muscle makeup of a power athlete, which, and you and I have talked about this, that not that it validates, but at least it helps me understand why I have always gravitated towards that type of training. I've always seen great results from that type of training, and diets that are not necessarily in alignment with that type of training, keto, cough, cough, doesn't really help me with the physical side of performance. Now, that's not to say I don't love the mental part of keto. So with all that said, we are going to get into all that. But Dr. J, what's new in your research since we've talked last?
So I actually moved. Last time we talked, I was in Boston, and now I'm actually in Minnesota, where my family is from, my wife's family is from, and I'm working at the Mayo Clinic doing research on stem cells and epigenetics. It's just something that interests me, and I do a lot of consulting, actually DNA consulting with pro athletes. not a ton, but here and there. I'm working with somebody on the Mariners, a pitcher from the Seattle Mariners right now. And, I enjoy doing that because pro athletes especially are just extremely motivated. Mm-hmm. And, I just like working with those people and really, really optimizing the performance, because not a lot of people are doing what we're doing right now on the air, which is talking about DNA and personalizing it and optimizing, diet, exercise, sleep, all this stuff based on your genetics. So it gives people an edge right now because, like I said, not a lot of people are doing it. So that's an advantage. And working at the Mayo Clinic has been really nice, actually. It's amazing. What's funny about the Mayo, too, is they've got underground tunnels throughout the whole clinic because it's so cold here in Minnesota. It's amazing. You wouldn't believe the amount of underground tunneling. It just carpeted, little hallways. You just walk around from building to building. That
comes in handy when you're buried under feet of snow in January.
Yeah, it's pretty funny.
I had a buddy that went to college in Boston, actually, and they had a little bit of that.
Oh, man. A couple of years ago, I think it was 2 years ago, it was just insane snow in Boston. Yeah.
It's pretty smart to set it up that way. Although it does prevent some sun exposure for all of our biohackers.
Yeah. Well, in the winter, you don't get the sun anyways, but yeah.
Right. Okay. So let's dive in with what we're doing today.
Cool.
Like we've said, 23andMe gives you a bunch of raw data. If you don't know how to interpret it, it's basically useless. One of the things, I didn't even know this could be done. So for you guys listening, this was part of how I had to get my information to Dr. J. If you've done 23andMe, you can log in, go to tools, and then you can go to browse raw data, which is completely different from any of the reports that they present to you. And like I said, I didn't even know that was there. So then I downloaded that document and emailed that to Dr. J. So
yeah, that's a great aspect of 23andMe. Some companies don't do that. They don't give you your own data.
Right.
And I mean, that's worth the $100. So it does cost $100 to, have 23andMe do your data, to sequence this aspect of your DNA. But, they kind of recently they've changed it. They have $100 for your ancestry, which again tells you where you're from, tells you you're British, whatever. And then they have for an additional $100, they give you a report. But like we kind of hinted at the beginning, the report that they give you it's really safe. They don't want to step on any toes in the FDA, and they don't really tell you that much valuable information because they don't want to harm the reputation of their company, of course. They're really known for sequencing the DNA, not really known for interpreting the DNA. But what they do, just so people know, and a lot of people know this, I guess, but what they do is they sequence your SNPs. They're called single nucleotide polymorphisms. They're looking at changes in your DNA. Some people call them mutations. And it's important to know that, I prefer to call them variants because, these single changes in your DNA, to call them a mutation is a little bit broad and a little bit inaccurate because, mutation usually means something more rare, more random, whereas SNPs, single nucleotide polymorphisms, SNPs, they're usually abbreviated. They're actually pretty common in the population. So, for example, and by the way, they're extremely powerful. So, for example, cystic fibrosis happens because of a SNP, because of a single DNA change. And it's common enough that when you see that single DNA change, again, it's called the gene variant. That's what I prefer to call it. When you see that variant in the DNA, that somebody's going to have cystic fibrosis. They're going to have problems with clearing mucus from their lungs, for example. Another big one is sickle cell anemia. One SNP, one change in your DNA, single nucleotide, right? Just that small gene variant causes sickle cell anemia, which is essentially your red blood cells. Instead of being a nice round donut, they look like little sickles. They're little horseshoe-shaped cells, and they don't carry oxygen as well, which can be a problem. And that's all just from that single DNA change. And again, it's some people call it a mutation. I'm okay with that. I prefer to call it a variant because it's commonly found. And that's what I look for. When I'm looking at the 23andMe data, I'm looking for these gene variants that a lot of scientists are studying and, publishing papers on and saying, look, you have this small change in your DNA and that leads to this health problem, like the MTHFR gene, which we'll talk about. Mm-hmm. So it's pretty simple in that regard, right? I mean, the SNPs, the single polymorphisms, and a lot of people complain about that. They say, well, 23andMe doesn't do your whole DNA. They don't do your whole genome, which, by the way, costs about $1,000. I also do analysis for that, usually through Illumina. The company is called Illumina. But the thing about the $1,000, protocol when you do your whole DNA is they don't tell you much more information. I mean, they give you all the DNA, but scientists don't know that much about all of that DNA. Honestly, what we really know a lot about is these SNPs, these single nucleotide polymorphisms. So that's what you're looking at anyways.
Right.
So that's where 23andMe is really valuable, is they give you the raw data, and it's the SNPs, these single gene variants, and that's what we know a lot about in science anyway. Mm-hmm. And so that's a really valuable tool. Okay. Now, the problem with that recently is that I was doing somebody's DNA analysis, I don't know, a couple weeks ago, and I was running up against a lot of false positive, just basically no answers. Mm-hmm. I was coming up where the genes that I normally would look at, they weren't showing up. And I called 23andMe and sat on hold for a long time and eventually got a hold of an actual scientist who works there. And I said, what's going on with this gene and this gene and this code? And again, they're giving me the code and I'm looking at the code and saying, here's the health problem. But their code wasn't even there. And the scientist said essentially what they did was they changed their sequencing, and I have a picture of it here. And it's literally these highlighted regions that I highlighted. I used to be able to tell people about those genes, but I can't anymore because 23andMe isn't even sequencing those. They cut their service to about 50%. In other words, a couple of years ago when I did DNA analysis for people, I was able to tell them 50% more information, and they removed that information simply because they don't report on it. And so I was frustrated by that because I reported on it. That was valuable information to me. And I'll bring up some specific examples of genes that they no longer look at, but just to give you a sense of how important they are. But I think first, maybe we should talk about your specific DNA variants.
Yeah, let's do that. And I'm curious, like from a really high level view, as you get this data, what are you looking at first? Is it sort of like a triage situation for you?
Well, I use a few different proprietary software programs, that just kind of decode the information, and because it's letters, right? DNA is A's, T's, G's, and C's. It's just thousands of letters.
Right.
It's those 4 letters, but it's thousands of those, the letters of code. But what I do is I try and break it down into detox genes. I just look at 58 genes that are involved in getting toxins out of your body, and especially in your liver. Okay. And just how functional are those enzymes or those genes in your body? Because that's really important and really practical. That's my main goal, is to have something practical for people. So in other words, like, for example, if you have problems clearing aluminum from your body, well, then you don't want to cook with aluminum foil, right? And because that might be an issue for you. You're going to have more aluminum toxicity. That's a neurotoxin if it's building up. So, that's a really specific practical thing, and it can change based on your DNA. So little things like that I look at. That's the first part. I do a 3-part report. Detox is the first part. The second part is disease risk. And that just kind of indicates to people what they might, what they want to watch out for in terms of diseases. You can oftentimes change your diet to prevent a lot of these diseases. And of course, I make recommendations for that. And then the third part is athletic profile. And again, 23andMe has removed so much of their DNA sequencing that I no longer can really, they've kind of stripped a lot of the information from me, and I can't use 23andMe as well to tell people about their heart rate variability, their response to heart rate training, their lactic acid threshold. I used to be able to tell them all about this stuff. Their power / endurance mix of muscle fiber types. Like, there was a lot more information there. They've stripped a lot of it. Wow. But there's still something there, and I still do an analysis of that. So that's the 3 parts: detox, health risk, and athletic profile.
Okay. Well, let's go through mine and, talk about, what you found and the significance of those genes. And,
Cool.
Like I told you before, I mean, you can say whatever you want. You don't have to hold anything back. I see there's one on here with the ApoE3 and ApoE4. You can talk about that too.
Okay. Yeah. I highlighted those just in case you didn't want me to bring it up, but nothing crazy. Nothing. You're pretty good. But let's start with detox, because I think there's the most to talk about there. And if we start running out of time, I don't want to run out of time on that.
Okay.
And that's the first part of the DNA report. Anyways, I have it printed off here for people to look at if they're watching on YouTube, which hopefully they are, because it's kind of interesting to see. And what I did here is I analyzed 58 different genes that are involved in detox. And the only thing I listed here for you was the areas that you might have an issue with. And so I list those as plus, minus, or plus, plus. Now, what that means is essentially either you've got a defective copy from your mom or from your dad. That would be a plus minus. If you had a good copy from your dad and a bad copy from your mom of the DNA, that's a plus minus.
Okay.
And sometimes your body can override that. So in other words, you're a carrier. You might be a carrier for something, but it doesn't necessarily impact your health if you have a plus minus. But if you have a plus plus, that means you have a less than optimal gene from your dad and a less than optimal gene from your mom. And so those are the ones I'm really looking for. And you only had 4, which is good. I mean, some people have 10 detox gene problems from their mom and dad. And, the specific ones that you had, as you can see, it's kind of like code. It's CYP1A2.
Yeah.
And I didn't make the names up, so I can't, I don't have any control over that. But that's the first one that, I flagged.
Okay.
As a plus plus in you. So in other words, you got a copy from your mom and your dad of this, like I said, less than optimal. It still works, but it's less than optimal CYP1A2. So what I do for people when I do consulting, including you here, before the show, I had you pull up my website, which is ajconsultingcompany.com. And then I have a specific page on my website that's called a mutation key. It's ajconsultingcompany.com/mutation key.
Yep. We'll put a link to that on the show notes for people.
Good call. Yeah. And essentially in that mutation key, the first part, detox, and you're probably on that page right now, Ryan.
Yep. I like how you have it broken down. The very first part says for the layperson.
Yeah. Yeah.
Which is, that's a nod to what you put in your Twitter bio about being a simplifier. Yeah. Yeah.
You have to. I mean, it's frustrating how complex these things are. And just the titles, right? Like I said, CYP1A2, it sounds daunting. And what that stands for is cytochrome P450, family 1, subfamily A, polypeptide 2. So that it's this long name, but cytochrome P450s are really common enzymes in your liver that are involved in breaking things down, breaking, drugs down. And so that specific one, in your case, you see how there's CYP1A2 and then it says 164A-C.
Yep.
What that means, A is the abbreviation for alanine. That's an amino acid. And C is the abbreviation for cysteine. That's kind of the shorthand. So what that means, what I'm trying to communicate here, or what the DNA is communicating, is that normally you would have an alanine, but instead you have a cysteine there. That's the change that you have. And that has a functional difference. In other words, the gene doesn't work optimally because there's that one change from an alanine to a cysteine. And again, you got a copy from your mom and your dad in this case. So that means in your cytochrome P450, family 1A, family 1, subfamily A, polypeptide 2, right? And again, that's just abbreviated CYP1A2. And yours is suboptimal. And what this enzyme does is it breaks down polycyclic aromatic hydrocarbons. Those are found in smoke. So in other words, for you specifically, you're not as good at clearing smoke from your body. So you definitely don't want to be a smoker because you're at a higher risk for health problems if you smoke than normal people. But even sometimes campfires and things, you don't want to be just getting blasted by smoke, because this gene is involved in clearing out those hydrocarbons. But even more important, caffeine. So you're not as you may have experience with this, but your body doesn't break down caffeine nearly as fast as normal people. So that would be, you'd be considered a slow metabolizer of caffeine. Right. So when you drink coffee, it'll probably stay in your system literally 8 hours at least.
And I have a personal rule where I won't drink coffee after 1 or 2 p.m. because I've noticed that. Yeah, any caffeine late in the day keeps me awake. So that's
perfect. Yeah,
It's really interesting to see this. Yeah, it's crazy because I am very sensitive to smoke. If somebody is smoking around me, I'm very aware of it and very I don't want to say offended, but it's bothersome.
Yep, that's good. That's your body saying, I'm not as good at breaking down this stuff. Mm-hmm. Don't breathe it in. And that's what, and just so listeners know, this is not rehearsed. We didn't pre-plan any of this, but it's always uncanny how accurate the DNA is in terms of, your health and how personal it is.
Right. Well, I mean, you can't fake DNA. You can't lie about it. I mean, like it is kind of who you are. So,
well, and the other thing that people sometimes, complain about is how repeatable is this? So if you send in multiple samples to 23andMe, how repeatable? The reason I like 23andMe is because they have a 99.7% repeatability. So they can replicate this just to crazy accuracy. As a scientist, I can tell you that that's good accuracy, and so they do a good job at 23andMe. That's something I don't complain about.
Right. There is one thing in this particular report on your webpage where you're explaining this information to people. I want to bring it up because I think it's pertinent to our listeners. They will be aware of some of these terminologies. And, I see the word aflatoxin in here. And it says in bold, aflatoxin is one of the most carcinogenic substances known to science. People with this particular variation are less able to clear these substances, meaning that they would be more sensitive, more susceptible to exposure.
Yep. Which is you, by the way.
Right. Which is me. And I think famously, somebody like Dave Asprey probably has this variation because a lot of what he talks about with bulletproof coffee, moldy coffee, you can argue till you're blue in the face about quality of coffee and the ethics and the morality around some of those businesses, but the bottom line is there is one of the things that you have written in here was avoiding I lost it, but it said avoid cheap coffee.
Yeah, for sure. And grains are a big one in America.
I think it says peanuts in here somewhere too.
Peanuts are huge.
Anything that is a mass stored product that can develop mold. Yeah, it's at the top in that red section. Avoid grains, peanuts, other mass stored products that have been may have been moldy, even super cheap coffee. Try to eliminate them from your diet. So
and that especially pertains to you. Yeah,
right. And that is something where I have felt sensitivity to certain things. And when I say sensitivity, I'm very in tune with how I feel after eating certain things. And there are things that make me very sleepy or very tired a few hours after eating them. And, I don't want to do that. So I have eliminated quite a few foods, that make me feel that way. So it is interesting to see that, there is a genetic component to this.
Yeah, for sure. And the other one on there was with that same enzyme, besides aflatoxin, was acetaminophen.
Yeah.
So essentially, if you take Tylenol, you probably don't feel this because it's not as noticeable, but it stays in your body longer than most people because your body doesn't break it down as well. It might even last up to 2 times as long. So you got to be careful with that one because you don't want to over supplement Tylenol and just, essentially you would be overdosing it where normal people wouldn't be overdosing it because it's just staying in your body. So that's how just for people that aren't actually looking, what I did a long time ago when I started doing this DNA consulting was I kind of made an accordion on my website. It's called an accordion, which means, these genes are listed, but then as you click them, it kind of gives you a scroll down, little write-up, a little blurb about the gene. And so because most people don't have that many mutations, right? You've got 4, some people have 5, 6, 7, 8, 9, 10. So you don't have to look at all 58 of these, The only ones that you're interested in, that I'm interested in today, are the ones that affect you. And again, in this case, it's CYP, whatever the numbers are.
Right.
And so then you just look that up on my website and you hit that little gene, and then it has a little scroll down, and then you read about that specific one. So if you want, we can move on to the next one.
Yeah, let's do that.
So the next one for you was another cytochrome P450. It's called CYP2D6. And again, this one's S486 to T. So that's, the serine amino acid was changed to a threonine, I think is what T stands for. So again, plus. So you got this variant from your mom and from your dad. It's less than optimal. And let's talk about it. So again, on the website, if you look up CYP2D6, it gives you a bunch of information about what it's called, where it's found in your body, and what it does. So this one, let's see, caffeine, ibuprofen, acetaminophen, let me think, 20. So essentially this one's involved in the breakdown of about 25% of commonly prescribed drugs. Mm-hmm. And that's important because obviously, if you're being prescribed a drug and it's not being broken down in your body, you're going to have more side effects. So you can literally just Google this gene, CYP2D6, and which drugs, say you go to the doctor and he prescribes you something. You can just go on Google and type in the name of the drug he prescribed you, mm-hmm. and this gene. And if there's some kind of a relationship, like this enzyme breaks that drug down, then you want to be careful with that drug. Maybe dose yourself at half. Most medical doctors aren't going to be this person. Well, virtually no doctor is going to be this personalized.
Even if they want to, they don't have time.
Yeah, unfortunately, because hopefully in the future we'll have like a more kind of standardized approach to doing this, and it'll just come right up on your medical chart. But yeah, exactly. And so you have to essentially watch out more for yourself in this regard. Mm-hmm. And the drugs, you can see I listed a whole list of them here on your report. I can't even pronounce all of them. Indomethacin, meloxicam, naproxen, piroxicam. You see there's a whole list of them. Again, that's not even an exhaustive list. There's a lot of drugs out there, and probably about 25% of them are broken down by this specific cytochrome P450. Your body doesn't, optimally perform with this enzyme. So just be careful and look that up whenever you have to, whenever you're prescribed a drug, I guess. Mm-hmm. So the next one, you only had 4. We just finished 2. So we're kind of cooking through this.
Yeah.
The next one is MAOA. And let's see if I wrote something down on that. It's methyl, it's an oxidase. I just have to find my notes. Otherwise I have to use my own webpage. I don't memorize all of these in case people are wondering, because there's just so many of them.
So what you wrote on the report sent to me just says adrenaline, serotonin, dopamine will stay in your body longer.
Just stays longer. Yeah, that's what I would have guessed off the top of my head. And so that's not really a huge health concern. It is important it's useful to know. It's kind of more just entertainment in that case. And a lot of people that have this specific gene variant that you have here, they like adrenaline more because it stays in their body longer. They get a little bit more of a high from it. Mm-hmm. So, I mean, again, not a health hazard by any stretch, but it's just good to know about yourself. It's specific to you. And if you don't have any questions on that, we'll just move to the last one.
Yeah, I mean, no questions. I think it does sort of explain some of my nature, my tendencies to, be a doer and kind of, I don't want to say chase actions that, produce dopamine and adrenaline, but
yeah. I got this. I have this one too. So I know, at least for me, I've done skydiving and all this stuff.
Right.
And I love it, but in terms of health, it's kind of neutral. But the next one, MTHFR, is called methyl tetrahydrofolate homocysteine methyltransferase reductase. You can see somebody had fun making that name up.
Yeah.
And these things all have meaning. Methyl is a certain chemistry group. Reductase means it reduces. This is all it's all pretty basic nomenclature for chemists, but again, we'll just call it MTHFR. And you've got a gene variant. And in this case, this one's interesting. You've probably heard of homocysteine because a lot of people check that for inflammation, and that's a good marker for inflammation. But in your case, this is closely tied to the MTR enzyme, which essentially makes methionine from homocysteine. So it gets some of the homocysteine out of your body. And because you have a gene variant in this, that usually means your homocysteine is going to naturally be a little bit higher. So you want to watch out for that. And the way to kind of mitigate that, again, so homocysteine is a marker for inflammations, and you don't want, systemic inflammation, high inflammation. You don't want homocysteine.
Right.
And because you're personally more disposed to having higher homocysteine levels, what I recommend for you and what I recommend for anybody with this gene issue, MTRR, is to supplement vitamin B12 every day, because this pathway, the MTR and the MTRR, they utilize vitamin B12 to convert homocysteine into methionine. So neutralize it, get rid of it. Methionine is just an amino acid. So you take homocysteine, break it down, using these enzymes with B12. So if you continuously maintain a high level of B12 in your body, it will help drive this reaction and lower inflammation. It sounds complicated, I know, but basically all I'm saying is just supplement B12 every day.
What's interesting is, again, we're talking about how some of this, I don't want to say validates, but it explains, some of my subjective experiences. And I don't take a multivitamin. I find that the ones that are affordable are actually crap, and the ones that are better quality are ridiculously expensive when it comes to multivitamins. So I tend to take single vitamins like vitamin D or vitamin C. Obviously, I take the Natural Stacks version of those. But I do take a B complex, and I take it daily. And when I guess I've sort of, over the years, I've tinkered with so many different supplements that, that was one that stays in my rotation, because when I don't take it, I notice a difference. Yeah.
Well, and I'm glad it's a complex, because normally, like I said, I only bring up the plus genes, which is basically genes you got, the problematic genes you got from your mom and from your dad. But the one gene I am going to bring up on your report that's plus minus, which means you only got a bad copy from your mom or your dad, not both, is the MTHFR gene. And I know that's a big one.
Yep. And I was going to ask you to talk about that one anyway, because it is such a big one.
Yeah. And I'm actually writing a whole book on this, because there isn't a book on this.
Oh, wow.
And it's such I personally have a plus in this one.
Okay.
And man, I've seen so many miscarriages when I do consulting. People come to me, they have fertility problems. I talk about artificial estrogens a lot.
Right.
And I recently just had somebody who's been unable to conceive forever. They've had all kinds of miscarriages, and they not only had the MTHFR gene, but they also were just, loading their bodies with artificial estrogen chemicals. And they've removed those about 6 months ago, and they're literally having their first baby, in a month or two.
Wow.
So this stuff totally works. And I personally think one of the reasons miscarriages are so high in America, besides just the stuff I wrote about in my first book, Estrogeneration, is the MTHFR gene. And really a lot of people I like to call it Monday, Thursday, Friday. That's probably what I'll title my book. Because if you picture MTHFR, you kind of know what it might kind of stand for.
Right.
But it's easier to remember if you think Monday, Thursday, Friday, MTHFR. And what that does essentially, in really layman's terms, is it essentially takes folic acid and converts it to a usable form called methylfolate. Again, that's a little bit oversimplified, but it works, and it's a real thing. And like, folic acid is a fake chemical. It was developed in a lab. It's not found in nature. And your body has to convert that using this MTHFR enzyme to methylfolate, which is a natural thing. And you find that, for example, in spinach. So people that eat a lot of spinach, they usually have plenty of methylfolate. But here's the problem. When we're supplementing a lot of folic acid and we're not able to convert it to methylfolate, it stays in your blood, and literally it makes things worse. It's actually worse to supplement folic acid. because it blocks receptors. It looks real similar to methylfolate, and it sticks on everything, and it kind of gums up the system. Again, layman's terms, but so this enzyme is critical for converting folic acid to methylfolate, and you don't have a plus like I do. You've got a plus minus, again, which means one of your copies is a problem. One of your parents gave you the bad variant for this. And what that means specifically, according to scientific research, is your body is 30% less able to convert folic acid to methylfolate. There's literally, I think, 3,000 publications, scientific research papers on this. And if you had a plus like I do, you would be 65% less efficient in converting folic acid. So that's a serious concern. I think 30% less efficient is enough of a concern, not to supplement folic acid, use methylfolate for you.
Right. What's interesting is this is very complimentary of Abelard Lindsay, the product formulator for a lot of the natural stack stuff. He made sure that methylfolate is the version used in dopamine brain food and some of the other products that, where that may be necessary for that very reason.
I know. And it's amazing how many good supplements forget that. Good supplement companies forget that.
Yep.
I come across a ton of them. People asking me, what about this one? What about that one? And I just look for folic acid, and boom, it's in there. It's not methylfolate. So I'm glad yours is methylfolate.
I was not aware until you just said it, that folic acid is not natural.
Yeah, correct. It used to be patented. And it's easy to make in a lab, but no, it's not a natural chemical. It's close, right? Your enzyme should be able to convert it, but and you don't see health problems with people that don't have the mutation because they convert it readily. It's fine. Mm-hmm. But all this advice, this idea that, you're pregnant, so you need to supplement folic acid, can actually harm you. It can be worse. And the reason folic acid or methylfolate actually is so important is because it's the building blocks for your DNA. That's how your body makes DNA, certain base pairs of your DNA. So if you don't have enough methylfolate, you're not going to be able to make a lot of DNA. That's a problem, obviously, in terms of babies, because you've got a baby, a fetus in the womb. Cells are dividing rapidly. They're growing like crazy. They need a ton of DNA. And where do they get it? Well, they got to make it from methylfolate. So if you're a woman and you can't take folic acid and convert it to methylfolate, you can see the problem, how that would cause a miscarriage. And it does. I mean, that's the sad thing. And if you go to a genetic counselor about this, it'll literally cost you $5,000 just to look at this one gene. Or you can go to 23andMe, send it to me, and I'll do it for you for, like $20 or whatever. I'll just give you a decent report. What I generally do for people is I don't have a lot of time. So I do really thorough analysis for real high performers, but I do want to help everybody. I'm not really in it to make money. I make plenty of money in other ways, and running my companies, and Mayo Clinic pays me and all this. But I want to help people with the supplements, and that's pretty easy. Right. And so I can do these really quick reports for people for like $50. If you have 23andMe data, it's not that complicated. What gets complicated is sitting down like you and I are doing and talking for an hour or two.
Right.
And that's obviously kind of like the next level up in consulting. But yeah.
All right. And we'll have a link for your site on the show notes for people if they want to, talk to you about the, that supplement protocol.
Yeah.
Okay.
Thanks.
So the only other one that was on the detox page that you wrote in the write-up for me was this GSTT1, says present, good. 15% of the population is missing this gene. As in not even a variant, but just missing it?
Correct, yeah.
How does that happen?
I don't know. So somebody way back in our ancestry, just essentially as their body was replicating as a fetus, as the body was replicating the gene, it just somehow had an error. Maybe there was some UV damage, maybe radioactivity. There's a DNA break, and the body just skipped over.
Wow.
It's crazy, and it's involved in glutathione, making glutathione, which is literally your body's, detox protein. It's your body's main antioxidant for heavy metals and all kinds of things. Whenever you need antioxidants, glutathione is a lot more important than, anything you get from your diet. But the crazy thing about that one is because you had your 23andMe done, I don't know, a year ago, you said?
Something like that.
At least.
Yeah.
23andMe no longer even looks at that. They don't even tell you the information on the GSTT1 gene.
Oh, wow. So that's one of the ones
you did yours a while ago. Yeah.
Yeah, that's one of the ones they cut. Okay.
They cut that one. In fact, let me give you, before we move on, let me just tell you some of the other ones that they cut.
Yeah.
And and there's only, I listed about 4 of them. Like I said, there's literally 50% of them they cut out of 58. So there's over 20 of them that they cut.
Wow. And
I consider them all important. But this first one that I listed a couple just as examples to show you what data we're missing now. I'm not even able to tell you about because they removed it. They don't even give me the information. And the first one on that is called ACAT. That's ACAT1. What that stands for is acetyl-CoA acetyltransferase. So again, you can see why I call it ACAT, and scientists call it ACAT. And what that one is involved in, it's involved in breaking down proteins and especially fats from your diet. So most notably, that gene plays a major role in ketone breakdown and how your body responds to ketosis, ketosis, the keto diet. Mm-hmm. And again, I can't even tell you what your status is on that because 23andMe no longer do that gene. They no longer sequence that aspect of your gene. Oh, so it's unfortunate. Yeah, because I used to be able to tell people about that one. It's on my website, but I'm especially curious now that you said something about ketosis in your specific case. But I can't. Again, they pulled that one. Another one that they've removed that they used to tell me about, but they don't, is called AHCY. That's the abbreviation. It's adenylocystyl homocysteinase. It's just another enzyme. Again, I'm not a super expert in it, but it's involved in a process of breaking down methionine into adenosine. And adenosine is really important. So, when people have that gene issue, I tell them to supplement adenosine. Okay. But again, I can't tell them about it because 23andMe no longer even, informs you on that gene. They don't sequence that one. Wow. So you can see, there's kind of this pattern here with these. There's a lot of important ones. I'll give you one more. I don't want to spend a ton of time. But another one that they no longer tell you about is CYP2D6. Again, that's another cytochrome P450. It's in the liver. It's a liver detox gene. And that one is involved. You know how you had that gene issue with 25% of commonly prescribed drugs? Right. This enzyme is 25% of other commonly prescribed drugs. It's another 25%, Wow. There's certain liver enzymes that break down a lot of these artificial drugs. Mm-hmm. And this is one of them. And 23andMe no longer even tells you about your status on that. And I mean, these are, again, real important things to know if you're getting prescribed a drug and they're staying in your body a lot longer because you're going to have more side effects. Yeah. Is there anything that the public can do to sort of try to urge 23andMe to give that data again? I don't know. I mean, it's not like they don't have the capability to do it. They used to. Yep. Yeah, I think they're using it as a little bit of leverage because they want to cut people off like me. Mm-hmm. When I called them, I was complaining about it, and they said, "Well, technically, you can just only inform people for entertainment purposes." That's how they like to describe it. That's kind of the legal way of saying, you don't really you don't provide any value. But I know better than that, but there's a lot of red tape around what can be said, can't be said, claims. Yep. Right? No, I understand that, and that's really what it comes down to. It's more about that. So if people hashtag Dr. J this episode, retweet it and add 23andMe on there, that's probably the best you can do, and that helps. It goes a long ways to complain. Hashtag give us our data. Right. Something. Good idea. Let's do it. You can't patent my DNA. Yeah. So is 23andMe the only place people can go to get this information? I know Ancestry.com has a report. Do they give the same raw data? They sometimes do, yeah. I don't work with them as much, so I don't keep up. These companies are constantly shifting what they do and what they don't do, and how restrictive. 23 is a perfect example. 23andMe is a perfect example. But yeah, I mean, I generally do use 23andMe. I start with them, even with pro athletes. I kind of start there because, you know, they provide a lot of value for $100. I mean, it's a really incredible amount of value. Right. It's frustrating that they removed a lot of the, like 50% of the value, but it's still a lot of value even with that. So I start there, and then I go to a full genome sequence or something like that.
Okay. Right.
But for the layperson, I mean, it's valuable.
Right.
And that's all on Detox. I mean, that's
okay.
Your Detox.
Well, let's move to risk, and we'll get through a little bit of this, and we'll touch on the athletic stuff before we run out of time.
Well, let's end on risk, because athletic, I used to have a lot more on athletic again, but essentially we know that you're, I kind of included that in this risk portion because we know that you're a fast twitch muscle fiber type.
Right.
And that's about all 23andMe is allowing me to say now. So even though it was about a year ago, they removed that a long time. They removed that about a year and a half ago or so, or whatever. They removed it before you even had yours. So yeah, unfortunately, I can't tell you as much about your athletic profile.
Okay.
So yeah, I mean, I wasn't going to mention this, but we talked a little bit about it before the show because it's confidential. But essentially, within your family, within your DNA, you have a 18.5-fold increased risk for type 1 diabetes. So that one's by far the highest of any of your health risks. And that doesn't mean, of course, that you automatically get type 1 diabetes. It just means you have a higher risk for it. And you can mitigate that risk, obviously, by, being cautious with sugar. Obviously, type 1 is more genetic than type 2. Mm-hmm. But I mean, it is what it is. That's just the information that I have.
Yeah. And I've said this many times. I'm not sure how many of those were on the podcast or not. I'm the only male in my family who's not diabetic, at least on my dad's side. My dad has 3 brothers. His youngest brother was type 1 from a very, very early age. My dad and his older brother are type 2. And that sort of family history was one of the things that got me interested in nutrition when I was in college and ultimately kind of set me on the path that I've been on. So I have no problem telling people, diabetes runs in my family, but, to see this number, that's pretty crazy. 18.5-fold.
That's pretty high.
That's not 18.5%. That's 18.5.
That's fold.
Yeah.
Yep. And I mean, like I say, I listed a bunch here for you to look at later, but the other one that's interesting that I'll probably bring up is that you have a 2.5 or 2.7-fold increased risk of age-related macular degeneration. Mm-hmm. And the reason I bring that one up specifically is because you want to be more vigilant in your case to supplement vitamin C, vitamin E, lutein, zeaxanthine, zinc, copper. So things that are essentially involved in, eye health, optical health, and function. And one of the interesting things about lutein, I'm sure you've heard of it, but not a lot of people supplement it. Not a lot of people need to supplement it. But I think if you've got this risk for macular degeneration, you probably should supplement it. Mm-hmm. What's interesting about it is plants don't make it. Animals do. So if you're a vegetarian, you can get it, your body can make it, but it's better to get it from animal products, from eating meat. And that's true in a lot of cases. It's interesting. I don't have any moral problems with vegetarians, and I love vegetarians. A lot of them are really healthy because they're intentional about it. They're really being careful with their diet. Right. But they do have, it's not a natural diet in my opinion, because, the human body is, I should probably write a book about this. I have a lot of thoughts on this, but essentially the human body is not particularly efficient at making our own cholesterol, making our own vitamin D, or vitamin C. Like for example, mice and rats, most mammals make their own vitamin C. They don't even need to supplement it. They make it in their bodies. Whereas humans, we don't make it. We have to eat it. And lutein is a similar thing where, we can make it, but we don't make it very well. So it's better just to eat it. And again, animal products, that's where you're going to find it. It's kind of like the K2, or the B vitamins. There's a lot of examples like this.
Right.
And it's a compelling argument to say that humans are naturally adapted to eating animal products, meats, and obviously with our industrial meats nowadays, there's a risk there. But anyways, that's a little tangent for you.
Yeah. What's interesting about lutein is I recently, maybe in the last week, I've seen an advertisement for a product now called Lutein Blue, and it's specifically being advertised and marketed to mitigate eye damage from blue light.
Oh, interesting.
Right.
I don't know anything. I know blue light can be an issue with sleep, but I don't know anything about lutein. That sounds like something worth checking into.
Yeah, I haven't had a chance to follow up on that, but just the fact that there are now supplement companies looking into supplements to mitigate blue light, and it was funny. It was like at the end of the ad, it was like, or you could just stop looking at your cell phone and actually have a real conversation.
Yeah, exactly. That's what I would have said. Shoot. So let's move on. Let's go down to some of the other ones in the section called additional notable genetic variations.
Yep. Because
some of that's useful and some of it's entertaining. And I think for the audience, they're going to want a little bit more of the entertainment value.
Right.
So for you, I'm going to jump around a little bit, and because I know you're following this on your side.
Yep.
But you're likely to lose 2.5-fold more weight on a low-fat diet, which is interesting. So, some people actually eating a high-fat diet works really well for them genetically. In your case, it doesn't. I don't know if you have any experience on that. That's just what the DNA suggests to me. So low-fat probably works better for you.
Yeah, when I was in the bodybuilding and modeling portion of my life, I got really, really lean following low-fat diets. Now, I felt awful, and my quality of life was not where I would have liked it to have been. So, that doesn't mean that makes a low-fat diet better. But as far as losing fat, I have experienced that. Yes. Interesting.
Yeah. And again, that's pretty specific to you.
Right.
So I'm not making a broad claim to everybody who's listening, but it's worth knowing that stuff can be personalized. Another one that's interesting is you personally have a better avoidance of errors just based on your DNA, but you have a slightly higher risk of OCD, obsessive compulsive. It doesn't mean you have OCD. It just means you're a higher risk for it. You have more of a tendency. And the specific gene for that is called ankyrin repeat and kinase domain containing 1. Just for people, they think that I'm just making this up, but that's the gene that's involved in that process.
Yep. So a friend of mine and I have a saying that we are very particular about our routines, and everything has a place as I go about my day. I know where things are, where they're supposed to be. And if they've been moved, we make this joke. We tell, we're both married. We tell our wives that, if you're going to move something, you might as well throw it away. Because if it's not where it's supposed to be. So I'm not calling myself.
He's probably got the same DNA thing.
Yeah. I'm not saying I'm OCD, but don't move my shit or I won't be able to solve it.
Yeah. And it's amazing that some of this stuff can be genetic when you think it's just purely something you grew up with, right?
Yeah. That's pretty crazy. And then let's touch on ApoE3 and ApoE4, just because I know that there's a lot of talk about that with dementia and Alzheimer's.
Yeah. So so I used to do Alzheimer's research. I did for 2 years. I developed viruses actually for the US government regarding Alzheimer's. Yeah. I used to consider it. Actually, that's how I started this consulting company. I was a virus designer. And what that means, essentially, I just created DNA and you put it inside cells, and then the cells make the virus for you. And then I would purify the virus out and give that, and sell that to labs. And the reason I was doing that, it sounds kind of like bioterrorism, but it wasn't.
Like, what do they do with these viruses?
Well, the reason I was doing it specifically to mitigate Alzheimer's or try and cure Alzheimer's. Okay. And so we had different animal models, and the hope and the intention was possibly to even inject viruses into humans, but obviously we weren't there, but we were just doing it in animals. And essentially viruses can be used to shut genes down or turn genes on. And so I was creating viruses that could manipulate genes. And ApoE is a good example of one of those genes, because if you've got 2 copies of ApoE4, so in other words, you've got ApoE. So let me back up. So ApoE is involved in cholesterol transport. And people should know, I mean, cholesterol is really healthy. Your body makes, it makes it from fat if you're not eating it. Now, again, just like the lutein and other things, your body prefers to just eat cholesterol. It preferentially takes it up, and it wants to just use it from your diet. But if you're starving yourself of cholesterol, your body can make it. It takes 20 different enzymes. It's a huge, complicated process, but it makes it. And the reason it's so important is about 1/3 of your brain by mass is made of cholesterol. Huge amount of your brain is cholesterol. So ApoE is involved in shuttling cholesterol around in your brain, especially. And anyways, again, like, I don't want to get too complicated. It's a long story. I don't want to take up too much time either. But essentially, there's different versions of ApoE. There's ApoE 1, 2, 3, and 4. And most people have ApoE 3, and that's pretty neutral to your health. It doesn't improve your health. It doesn't make it worse. But if you've got copies of ApoE 2, these are slightly different versions of this protein, you're at a really high risk of heart attacks. For some reason, I think it's because when you have inflammation, you get, injuries in your arteries, and then ApoE puts more cholesterol into your arteries than it should be, ApoE 2. But the ApoE 4 is just really associated with Alzheimer's risk. It's kind of considered the Alzheimer's gene. So when you have ApoE 3/ApoE 4, so you got a 3 from your mom or dad and a 4 from your mom. So you got 1 from your mom and 1 from your dad, 3 and 4. And that gives you a 2-fold increased risk for Alzheimer's. And that's good to know, because you can do a lot to mitigate that, especially in terms of sugar, which you already are really keyed in on. You don't want to be just constantly eating sugar all the time, drinking sugar, juices, fruits, obviously processed sugars, because there's no question that diabetes and just having insulin problems, sugar, just eating sugar all the time, are connected to Alzheimer's. And so is inflammation. So is, brain inactivity. If you're just vegging out all the time, watching TV, which obviously you're not, but, there's a higher risk for Alzheimer's. So there's certain things that you can kind of watch out for to mitigate that risk for Alzheimer's. And so it's good to know. It's a little bit scary, but it's not automatically meaning that you're going to get Alzheimer's. It just increases your risk 2-fold. Okay. So I don't know if you had any questions on that, but.
Well, I guess, I don't want to say it doesn't surprise me, but grandmothers on both sides have had Alzheimer's and dementia. So family history. And I guess my questions would be around, what can someone do if they have this genetic variation? And I think you've already said,
sugar's the big one. Yeah.
Sugar's the big one, and, sort of lifestyle, staying active, continue learning throughout your life.
Yep. And in fact, if you really want to go extreme, like say, for example, you had ApoE4/ApoE4, you had 2 copies of 4.
Right.
That's a really high risk for Alzheimer's. And in that case, I would recommend, a lot of ketosis, a lot of keto dieting, really being careful about sugar, supplementing a lot of good DHA, like krill oil, being real careful about inflammation. Essentially just, taking your health a lot more seriously than normal, because, that one, a lot of people get Alzheimer's at age 60, when they have 2 copies of that gene. So, in your case, you don't have that risk as much, but it's probably worth checking your wife's DNA or your, that kind of thing to see if she's a carrier, because I would consider it kind of a carrier status, even though it does increase risk too.
Okay. So let's talk about a couple of these other ones just for entertainment value then.
Why don't you pick them out? And
all right. Well, I'm scanning through this. I love the fact that it says I'm empathetic and likely to handle stress well.
That's good. A lot of people don't. That's because of your oxytocin receptor.
And that's not me saying it. That's my genes.
Yeah. Actually, it's amazing how many people have the opposite of that. They lack empathy.
Okay.
Because of a mutation in their oxytocin receptor. And, but yeah, you got the opposite. You got the good one.
That's really cool. Liking to have exceptional longevity. That's pretty cool.
Likely. I spelled that wrong. Likely.
Okay.
Sorry. Yeah, exactly. So yeah, that's the cat. So that's,
That's interesting. Talk about that lineage. I don't even know how to pronounce that.
Ashkenazi Jews generally have this gene in their cholesterol ester transferase protein. It's called CAT-P.
Okay.
And the FOXO3 gene. So it's kind of involved in sugar metabolism and things, but it's not racist. It's just that way that lineage of people have their genetic makeup.
Right.
Just to preempt that whole Twitter storm. But I mean, you've got that same exact gene fingerprint in this case, and cholesterol ester transferase. Again, I mentioned this before, so I'm actually kind of glad it's circling back to this, but mice ironically don't have cholesterol. A lot of animals don't have cholesterol ester transferase protein.
Okay.
And what that means is they can't transfer HDL and LDL cholesterol as well. They can't transfer cholesterol between HDL and LDL. That's what the CETP gene does, cholesterol esterase transfer. So essentially you have a version of that makes you healthier. It kind of, it allows your body not to utilize, it changes your utilization of cholesterol. Right. I'm trying to make it simple, not get down too much of a rabbit hole. Right. The whole point is it just increases your longevity, and that's well known from the specific lineage of people.
Huh, that's really cool. I don't know of any Jewish lineage, so maybe have to look into that. And
it's not specifically necessarily Jewish specifically, but it probably is way back in the day. Yeah, but in particular, this Ashkenazi Jew lineage, basically they all have this gene variant. Yeah.
Well, that's a rabbit hole for me to go down on a random weekend.
Yeah. Wikipedia.
So a mix of muscle types that supports my subjective experience. Fast twitch sprinter is the predominant one.
Yep.
Let's see. Increased memory performance.
Yep, that's a good one. Yeah. And like I listed the gene there for you. It's called kidney and brain expressed protein. 25% better memory performance, approximately in general with that gene. So that's a great thing for you.
Yeah. So I guess if somebody had, I guess maybe I have like minus on these on your like scoring system. So if somebody had
depends on the gene, but yeah. Yep.
So if somebody had plus and they had like, this could explain potentially memory reasons from a genetic standpoint.
Yep. Sometimes there's variations between short-term and long-term memories. Sometimes there's variations between stress and memories, how like some people have a better memory when they're under stress and some people it's the opposite.
Right.
So yeah, there's a lot of variation, but yeah.
Huh. That's really interesting.
Yeah, normal hangovers.
I'd beg to differ on that. Coming from a guy who retired from drinking because the hangovers were too bad. Actually, it wasn't the hangovers, but it was just...
Yeah, I mean,
I have to edit that.
Hangovers are never healthy, but... Anyway, so yeah, that's about it. I mean, I know we're going overtime a little bit already, but
yeah,
I figure if there's ever a time, this is so fun and entertaining.
Yeah, it is. And I want people to have, as much understanding as possible about, how much more there is to find out, from this information. It's you, and someone can tell you more about, what your DNA and genetics, have in store for you. Dr. J, where can people get more of you?
I would just recommend people either find me on Twitter. I just started an Instagram not too long ago. So you can watch my deer hunting adventures or whatever. And AJ Consulting Company is really my main website. Okay. So that's just, I abbreviate that with ajcco.com to make it easier to type sometimes, or you can just say ajconsultingcompany.com. Yeah.
Okay. We'll put a link to that on the show notes for you guys listening. Also on the show notes, I'll post maybe some screenshots of some of my information for you guys. If you want to see, what some of these reports look like, I'll maybe have to find a way to blur out some confidential stuff, but sure we can get that done. We'll have links to resources, studies, anything like that for you guys to go down as well. go to iTunes, leave us a 5-star review. Let us know how much you like the show. When we read your review on the air, we will hook you up with a care package as a thank you. And finally, share the OPP. You've got friends and family, people in your life that you know will benefit from the things that we're doing here. That's how we spread the message and get this information to more people. So, share it on Twitter, email it to someone you know, put it on Facebook, whatever. Dr. J, closing question. You have answered previously your top 3 tips to live optimal. So we're going to give you a slightly different version of it. Give us your top 3 books that you think every listener should read.
Wow.
Actually, you know what? Let me. We'll change it just slightly.
Oh man, I like that question.
All right. Well, the only change I was going to say is like, what are you reading now? Best book you've read in the last year, and then favorite book of all time.
Nice. Boy, I usually read a lot of books at the same time. Mm-hmm. I just finished Headstrong. I just finished the Telomere Effect. I'm just finishing the Plant Paradox, which actually I really enjoy.
Is that Michael Pollan? Or?
That's Gundry.
Oh, okay. Okay.
Honestly, I really liked that book. I really enjoyed it. I recommended it to a lot of people. So I'll add that one to the list. Plant Paradox, I would say people should read that.
Yeah.
It gives a lot of insight in a lot, people that have these dietary issues that they're really struggling with, and gluten just isn't cutting it. Check that book out. And another one I'll add to the top 3. So that's one. I'll leave mine off the list, even though I'm tempted to just put mine on there. But we'll
make sure we put a link to that. So
I just had somebody on Instagram say something real nice about my book. Said basically they couldn't put it down. They're just learning a ton of information. It was a medical doctor.
Oh, that's awesome.
Yeah, he said my book for the week, and then he had a picture of my book. He said, great information from Anthony GJ on the effects of modern society's environmental influence on our body, genetic expression, and hormone regulation. I'm about halfway through. I'm having a hard time putting it down. That's kind of the best compliment for that book.
Yeah, that's amazing. And that's why we had you on the show previously. So what did I say earlier? Is that episode 97? Go back and listen to that one, folks.
Yeah, you should. And the other books, the Plant Paradox, I really enjoyed, I have so many. Mercola's book, Fat for Fuel, is really good. I really liked it. I like Mercola in general, Dr. Joseph Mercola. And then it's funny because Mercola, he says he reads about 250 books a year. And I believe him. I mean, the guy is prolific. Mm-hmm. And he said his favorite book in this past year was called Tripping Over the Truth. And that's by, I think, Travis Christofferson. Mm-hmm. I don't want to get him mixed up with the country music singer, Chris Christopherson, but
it's definitely Chris Christopherson has done a lot of stuff in his life, but he didn't write that book.
He didn't write a book about cancer, but that book really opened my eyes.
Yep.
And I did a YouTube video on it because I was so impressed. So like Mercola, I want to throw that one in the list too.
Yeah. And that's, I'm looking for it because it's usually within reach of my desk, but it's not right now. That's a great book. And I would highly recommend that one to folks. One of the scientists featured in that book was Dr. Thomas Seyfried, who we've had on the show talking about the metabolism of cancer and a lot of that stuff. So I forget off the top of my head what number that episode was, but if you guys didn't catch it, go back and check that episode out. So, and if for some reason Travis hears this, we'd love to have Travis on the show. So just put that out there. Right. Well, Dr. J, this has been awesome. Thanks for hanging out with us. Thanks for all the information. And for you guys listening, thanks for being here once again. We'll catch you guys next week.
Thanks, Ryan.